Hi, Phil, and hi, Phil Scout Troop. Lovely that you're having me. I am at the University of Louisville. I am Benno Holverda, and I'm going to talk to you about Rubin's galaxy, a gentle giant. So I'm an astronomer, and so are all the other names beneath there. So I've put all the names there to make sure that you know that it's just not just me doing it. It is a whole team that's working on this. But Phil asked me, Scoutmaster Herb asked me to talk about, what it's like being an astronomer. What do you do with the Hubble Space Telescope? What do you do with telescopes? And of course I want to talk about that. That's lovely. So wonderful to see you all, and I hope to get questions from you, and I'll try to answer those at a later date. So if you have questions following this little video, send them to Mr. Herb, and he will send them on to me, and I'll try to answer them. Okay? So our question is today how to make a big galaxy. Like, not the small one, big galaxy. How to make a big galaxy. So let's see if the video plays. I'll quickly turn off the light for this part. So you can see there's two parts to it. The first part is dark matter. So this is this mysterious stuff that we think is everywhere in the universe, and it's stuff, right? So it's got gravity can pull things together, and as it's pulling things together, it's pulling the stars that are floating around in space and that are forming as well to it, right? So it's got gravity and it's pulling things in. So this is a huge box. This is a huge chunk of the universe where we've put in the computer, and we're just sped up time. We're running through the whole thing, and this is how we think like a really big galaxy forms. Like you start with a whole bunch of small ones. They start crashing into each other because they're in the center of like a big blob of dark matter. We still don't know what dark matter is. No idea. We just know it's there because we see this happening. We see these galaxies come together and make really big galaxies. Now, the really big galaxies tend to be red because the stars are old. Like a lot of the stars in there were old, and old stars are reddish, yellowish. And young stars tend to be blue, and they don't live very long, so you see them very briefly. Okay, so now I'm going to zoom in on a very special galaxy. Let's see if I can get the lights back on. Yep. So we're going to zoom in. I should wait with the lights. Sorry about that. We're going to zoom in on a galaxy. So what we see here are sort of what you can see in a good dark site. You can see these kind of stars. Those make up the constellations. You can already see that this is a picture with a telescope, because you can see all the little fainter stars that our eyes cannot pick up. Our eyes are great at seeing in the dark, but they're not so great at seeing the small, far away, faint stars, because your eyes are like video cameras. And your video camera or any other camera, they refresh. They become like they sort of forget what they saw just now and make a new picture. And so if you do that, you can only see whatever you can see in a second. So you see the bright stars, but you don't see the faint ones. And so as soon as you have a telescope, or you can take a picture with a photo camera, you can take a deeper picture, and you see the other stars appear. Now, you have the constellation Perseus here. So that's one of the heroes from Greek mythology on its side. So you can find Perseus. And if we zoom in and zoom in and zoom in and zoom in and zoom in, we start to see a little faint, fuzzy thing there. And these are all the stars that you can't see with the naked eye. You can't see it with your normal eyes, but you can see it with a telescope. And you realize that that's a galaxy. This is our special galaxy. This is Vera Rubin's galaxy. And you can see it looks very different from that product that we saw earlier. That big galaxy that was made out of all the small ones was completely orange. And this one has this blue arm sticking out very far. This star here is still in our Milky Way, so that's way in front of it. This galaxy is very, very far away, billions of light years away. quick bit of math, 210 billion light years away. And you see that the central part is orange, but the outer parts, the outer arms are blue. And so those are new. Those have been made recently. So I did that. That picture was taken with the Hubble Space Telescope. So the Hubble Space Telescope is as big as a bus. It's as big as a school bus. And I'm assuming that you all are very familiar how big a school bus is. And it's in space. So it's really good at taking a very sharp picture. But as you can see, it was only of a very small thing. So it's good at taking pictures of small things, taking sharp pictures of small things. Why do I keep calling it Rubin's galaxy? Well, this is Vera Rubin. She lived until 2016. She was a very nice grandmother-like person. And she was also a very good scientist. She was the person who studied this galaxy, or one of the first people to do that. And when she was doing that, she noticed that she saw evidence for that dark matter in there, but also that this galaxy was really big. So she took it on the sky and actually measured how big it was. And it's like, oh, it's far away, but it's very large. So just to give you an idea, this is the similar size of the Milky Way. So our galaxy is this big, and if you put it on the same scale, this is this particular galaxy called UGC 2885. That's the phone number. So we try to give it a better name, and it's like, all right, let's call this Rubin's galaxy. And what I noticed in 2016 is that the Hubble Space Telescope had looked at all those pictures. So she had made this little figure, this little comparison. Hubble had looked at all of these, well, not on our Milky Way. The Milky Way is too big on the sky, but everything else, but not this guy. So that's what we did. So making a picture like that, this is now flipped, but that was the easiest way to transition. You can see that you've got the big stars, you've got the blue arms, you've got the orange center. So another nearby galaxy. You see all these little red dots all over the place? That's galaxies that are even further away. The universe is huge. It's just humongous. So every time you look at something, you see a little bit of Milky Way. You see something nearby. You see galaxies far, far away. Now, the reason that we took this picture was to go study why you can make a galaxy so large, literally 5 times our own Milky Way across, and it still looks like just a spiral galaxy and has blue arms and all those things. So that's our mystery, and that's the one that we're studying. So we're trying to figure out how to make something this big and still make it look like a pretty spiral and not like a big orange blob. So as I said, we used the Hubble Space Telescope for that. Now, again, as big as a bus. These are the solar panels the astronauts put on a few years back. And this is the little antenna that sends, whenever it takes a picture, the cameras are in the back here. So the light comes in here, it takes a picture in the back, and then they send it back to Earth with those little antennas. And so you operate that from space. It's a really big deal when you get a little bit of time to do this. So what we did is actually we took 4 pictures around so we can have like one big nice picture of this galaxy. Now, one of the mysteries about this galaxy is that, is there a really big black hole in the center of it? If you have, typically for galaxies, if you have a really big galaxy, there's also a really big black hole sitting at the center. And so I was curious if that was the case. And so I needed some more information, especially about that little bit in the center. Now, we didn't have that information, so we had to go find it. And so looking at that very central bit, we took something called the spectrum. And so I think of that, we took a rainbow. If you do that, you've all seen rainbows, I hope, at least. If you go camping and see a rainbow, you're probably getting rained on. But you can split the light, you can split white light into all its colors. And that tells you what's in there. So you can tell, for example, if there's oxygen in there, or hydrogen, or carbon. And so that's how astronomers learn about what something is made of. And so we did that, right? We took pictures, so we took spectra, we took these little rainbows of the central bit with all kinds of different telescopes. And then We even dug out, thanks Bill Keel, we dug out a spectrum from 1983, and I think your Scoutmaster is younger than that. So we asked all kinds of people to look at this. So this is like every circle is like a different telescope having a look at this. It looks like there is a black hole. So this is the black line was what we predicted. This is like what we're comparison, and so the green line is sort of what you expect if there's a black hole. You expect these little spikes there. And we found them. So all the different telescopes agree that, yep, there is definitely a supermassive black hole there in the center, which is interesting because it must be lying low, because we don't see any other evidence. We just see it in the spectrum. We don't see it anywhere else that there is a supermassive black hole. Now, supermassive, what does that mean? We measure things for our own Milky Way or like galaxies. We measure them in solar masses, in like how many suns is it. And this galaxy is a 1,000 billion solar masses. So 1,000, if you know what a billion is, that's 1,000 millions. So it's a million millions of suns stuck together in this giant spiral. And so we think there might actually be a black hole that is like maybe a million suns worth of black hole sitting in the center, just very quietly. And so this will be something that we'll look at further. So that's what I do. This is just one example, but it's like I have a whole team of people. We all work together. We start figuring it out. We start asking for telescopes, or we go to telescopes and observe. So if you have questions about this, time to think up your best questions. Let me know. Tell the Scoutmaster. Tell Mr. Erb. And then he will send them to me. Write them down. I'll send them all to me, and I will make another little video explaining what we did, explaining what we know, and sometimes the answer will simply be, I don't know. And that's okay. That means we have something new to find out. All right. I hope this was fun. Let me know, and you'll hear from me as soon as I get your questions. I want good questions. All right. Thank you.